Okay, let's start it. This is a demo video created from group 20. The group number is Chen, Yixi, and Shuo. Well, let's start it. First, let's start the backend server. Now we can see that we open 5 terminal. That one of this represents the backend server. Okay, we can see that the backend server started successfully. And now let's start several client nodes. Okay, first, second, third one. Okay, let's start from the client server 1. Before I started, I need to mention that there is another blank terminal that will represent as the attacker's node. But in current stage, we didn't not to mention this, so let's start it from the stage 1. Okay, the first one, the task of the first one required us to generate. Wait a minute. Okay, for the task 1, okay, it requires us to generate the EPHID. Yeah, let's start it from the code part. We can see that the EPHID, which has 16 bytes and has been generated in the client node screen. And on the end of this line, we can see that there is a timestamp, which are used for us to clarify that this EPHID is generated whether after every 15 seconds or not. Yeah, we can compare the timestamps to check the result. Okay, let's see the code. We can see that we used the ECDSA library, and we use the EC algorithm and DH mechanism to generate the EPHID. Now we know the generator that the EPHID the bytes can start from the bytes. The length of the bytes of the generator of the EPHID will be up to 64 bytes or the 32 bytes. Now we need to use a compressor algorithm to compress the it to 17 bytes, and we will transfer it from the first byte to the last one. Well, the total length of this will be the 16 bytes. Okay, now we can see that the segment 1 has been completed. Okay, let's see the stage 2. Okay, the next mission for us is to generate the 5 shares, 5 share keys, and we can see that it has been generated in the client screen. Let's see the code. Okay, well, we can see that according to the specification of the assignment, we should use the Shamir. We need to use the Shamir ways to generate those keys, and according to the lectures too, according to the lectures as well, we should set the key and the n's. We should set key and n numbers to satisfy the requirement of the specification. Like we need to create 5 in total, and if the user, I mean the client node, received 3 of 5 in total, they should use this to build some thing for the next stage. For that stage, we can see that the key has been generated successfully, and we can see that we should use some wait a minute. Okay. Then we need to broadcast this. For the part of the broadcast, we need to broadcast it every 3 seconds. Per 3 seconds, we should to broadcast one key, and we can see here. Yeah, we can see it has been received in the client 2. Okay. Okay, let's move on to the next segment. For the segment 3A, that as I mentioned before, the shares that we should to send one share per 3 seconds over the UDP broadcast protocol. We designed the drop mechanism. Let's say the code. Let's open this sender. Okay, we can see here. We generate the drop function by here. That the drop rate we set is half. So when the number we generated from the random function, if it less than 0.5, we will drop this key, and else, then if it will be less than 0.5, we will drop this key. Else we will broadcast this key, and we should see we should see that the format of the message is contains the share key itself and its corresponding hash value. Yeah, we can see it from here. Okay, well, let's see this function. When we receive this one, when we receive the shared key, that we can see that we should use the vice versa. We should use the vice versa way to decode this message, and we can as I mentioned before, if we send this message, we need to transfer it from string to bytes. And on that and if we receive this, the client need to do the transfer to the let me see how to say this. Okay, when we receive this message, we need to transfer it from bytes to string. And yeah. Okay, let's move to the segment 3B. Okay, we can see it. The screen output a line that receiving a share from this. We can see that the first 3 number of numbers, it is the Unicode. It is a Unicode 3 bits, and we can see. Okay, let's see the code. We can see it here. Okay. Okay, we can see it in here. We separated each message we received, and we used this to generate a sender flag, which used the Unicode 3 bytes from the beginning to represent to represent the difference. Okay, let's move to the stage 3C. Okay. Okay. For each EPH ID. Okay. For each time we received a shared key, we should to storage it from, and we according to the Unicode flag, we can identify this share is belonging to which one. So we can identify if we generate it is a first shell, and the 2 shells we collect and the 3 shells we received from this. Okay. if we now we can see that if we receive the 3 or more than 3 number of shares, we should construct the EPH ID from the message we received. Okay, let's move to the segment 4A. We can see let's start from maybe let's start from the code part, I think. Okay, we can see it from here. This is in. Wait a minute, it's not in here. Sorry. Okay, we can see this function, the reconstruct sharing keys. As I mentioned before, if we receive the more than 3 numbers of shares, we can reconstruct the EPH ID that we wanted using the way like we generated from the in the former stage, in the former segment. So we can see that in the terminal. Okay, let's move to the client 1. We can see we can see that compare the hash used this EPH ID we just reconstructed, and to compare this value with its corresponding hash value, which has been sent at the same time from the broadcaster from the client who sent this, and we can see that if it is matched, I mean if the EPH ID we reconstructed match the EPH ID's corresponding hash value, we can see that it can be used to, then we can generate a ENC ID. Okay, let's okay, wait a minute. Okay, let's see how ENC ID has been generated. It's here. The function is here. Okay. We can see here that we use the EPH ID as a public key. Then we need to and we need to plus the private key that we already know. Then we can generate the shared secret key, which means it's EN which is a ENC which is a ENC ID. That can represent that if we use even the two clients use the different EPH IDs, but they still can generate the same ENC ID by using Diffie-Hellman key exchange mechanism. Okay, let's move to the next stage, which should be the stage 6. Okay. On that stage, our challenge is we should add this. We should according to the sender flag. Okay. Wait a minute. Okay. Let's see here. For this segment, we need to add this ENC ID to DBF, which aka the Dairy Bloom filter, and according to the sender flags that we used in the former segment, that wait a minute, segment 6. Let's see. Let's go over here. Wait a minute. Okay. Let's see here. If we want to add this ENC ID if we want to add this ENC ID into the DBF, we should first the first thing we need to do is to identify the maximum number of the DBF number is still is greater than the value we want to add. which means which means we need to check the DBF. The current DBF is can be added or not. Then we need to add this ENC ID to the DBF. Okay, let's see the screen. We can we can see we can see the segment 06 that the adding 6DA67 blah 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 to DBF, which means that this function has been developed. Okay, let's move to the next segment 7A. During that time, our task is to show the ENC ID has been added to the current DBF at which index. We know that the DBF can storage the maximum number of the DBF can storage is 6. So we use the different index to represent the different ENC ID and the numbers of ENC ID. We can see from the screen that there are 2 ENC IDs has been stored in the DBF, and we can see that there are 3 ENC IDs. Sorry, I mentioned before it's 2 ENC IDs, and now there are 3 ENC IDs in the DBF. According to the code, let's move to the code part. Wait a minute. Let's see. Segment 7A. 7A. Okay. Okay, we can see here that when we want to add this ENC ID, if the ENC ID if the ENC ID numbers of the current DBF is less than 6, we can storage it in 2. Else, the current DBF cannot be added. So okay. So we need the created field. There are how many numbers of the ENC ID has been exist in the DBF. So we can see that the all let me see the all ways the function run and can fix the requirement of the assignment. Okay, let's move to the next stage. Sorry, I forgot to mention that. I forgot to mention that in the segment 7B. In the segment 7B, I should mention that if the current DBF is full capacity, we need to create a new DBF from the nodes and in every 60 seconds, because sorry, my fault. The 90 seconds, which means the 1.5 minutes. Sorry. Okay, now we can move to the next stage. Okay, let me add on one words. It's here. We need to use this function to create a new DBF in every 90 seconds. And you can see that we set a time counter, and we set a time counter, and we used this function to create the new DBF if the condition if the condition is reset as I mentioned before. Okay, let's move to the next stage. For task 8, let's start from the code part. okay, we should combine. We should combine it. We should combine the Q. We should combine the QBF with the DBF with the DBF lists. So we can see that. Let me think how to say in English. Let's see that the QBF. Okay. Okay, we can see that the first we can see that the QBF we can first we need to use the QBF from the daily from filter, and we can see the origin format of the QBF is a bit array, and we should traverse the DBF lists to run the OR operation. The OR is OR to run the OR operation with use the QBF with each DBF, and we can see that each DBF each size of DBF is 100 KB, and so yeah, so we need to traverse the DBF lists to compare to run the OR operation with each DBF with the QBF, and to combine to combine the single QBF, and we can see that the period of this is every 9 minutes. Let's okay. If we let's see. Okay, let's see. Let's just see the code part first. After we combine this, we need to upload the QBF. Okay, we finished the stage 8. Now let's jump to the stage 10. That we on that stage we need to upload the QBF which we just generated. We can see that the payload. We can see that the payload of this the payload of the QBF's filter it's just a bit array. It's just a bit array. Okay. So so let's see the request is here. We use the request and to upload this one from the client server to the from the client node to the server node, and we can see that the TPC protocol has been implemented on that stage. Okay. Let's say the let's move to the segment. Oh, wait a minute. Let's move to the segment of the 10B. Let's see it from. Let's see the code part first. That 10B, 10B. Wait a minute. Okay. Okay, and we can see that if the post request has been if the QBF has been uploaded, the backend server should send a response to the node who sent this back. Okay, we can see it in let's see the let's see the terminal. For demonstration, we can hear that for demonstration we add a command like a Q, which means that we can see the script has been generated in here. That we already get a response from the server. Query doesn't match. You are safe. Which means okay. We can now let's see the backend server. Okay, from the backend server we can see that we can see that the performing the QBF the QBF operation has been rendered. We can see the feedbacks. I mean the response has been generated from the backend server. Okay. Now we can see. Let's see the code of this function. It's here. Okay. Okay, we can use we can use the calculation has been used here is to I mean the bits on this part we use the bits levels calculation to return the to calculate the result. Okay, let's see. Wait a minute. Okay, wait a minute. Let me see. Okay, we can go to now. Let's see the stage of to the upload to the upload part. Okay, my next issue. Okay, now let's try to upload the. Okay, let's try to upload one. We can see that we already send the. Sorry, I forgot to mention that we are moved to the stage 9, right? So we can see that after I used this command, used this command for demonstration, we can see that the message we want has been sent, has been sent to the backend server, which the command we used is to press C. We can see that. Okay, let's see the code part. Wait a minute. Okay, it's here. During the upload time, we need to add this filter to. Okay, wait a minute. On that time, we need to upload the CBF to the backend server as an array. Okay, so not so, and then let's say the terminals. Now we need to run the run the QBF again. Oh, now we can see that on this time we get the different response from the server that the server told us that we are potentially close the contact. The reason is the client 2 has been uploaded the CBF to the backend server, which operation is successfully. And during this time, we as the client 1 to send a query to the backend server to check if we are safe or not. Then, since we get the same the ENC IDs, the backend server will send the response to us that we are potentially close contact during after the CBF has been uploaded by client 2. Okay, let's move to the stage 11. On this time, we need to use the terminal, which is represented as the attackers. Let's run the code. Okay, need to zoom in it. It's easier to see. On that time, we can see that the attacker will receive the broadcast from the client node. It keeps receiving this. We can see that it can receive the broadcast from AD4, from AAF, from ED1, from something like this. It keep receiving like this format, and it will be rebroadcasting to the outside. Use the UDP protocol. Okay, let's see the code part. Okay, wait a minute. Okay, the attacker. We can see from the code that the attackers .py has been modified from the regular sender and the regular receivers. And we can see that we use 2 threads. The first thread is just is as a function to wait, and this function has been called, and we can use, and this thread will broadcast the message that we received. For the second thread that we use is this thread is keep listening the UDP port. We can see that if this thread is keep listening the UDP port, and if this broadcasting is not from ourselves, it will call the first thread and rebroadcast the message we wanted. There is one thing we need to there is one thing I need to mention. Almost forgot that there is a condition. There is a judgment condition that if the broadcast is sent from us, I mean, if we listen the rebroadcasting from ourselves, we should ignore it. So it can avoid the dead loop for infinite broadcasting for infinite rebroadcasting the message we received from that broadcasting. For example, if we received the broadcasting message from client 1 and we want to rebroadcasting it, and then we just keep listening, and then we listening the rebroadcast the message that we just used. So there is a dead loop. By adding this judgment conditions, we can avoid these things. Okay. Let's see this part. Okay. Okay, we can. Okay, I need to mention that why we need why we assume that the attackers will use the attack method like this. We assume attackers will start two kind of attacks. The first is this, which I just illustrate, is a relay relay attack. Which the second is a DOS attack. For the second one, I will mention in the next stage. On that part, if there are two clients, I mean client 1, client 2, if the client 1 is very far distance from client 2, on that circumstances, the broadcast from the client 1 cannot be heard by the client 2, which means that the client 2 shouldn't receive any message from the client 1 while using the UDP protocols, the UDP broadcast protocols. But if the attacker can receive a broadcast message from client 1 and use the way that we just illustrated to rebroadcast this message, during that time, if the client 2 received the rebroadcast message from the attackers, so the attacker 2 will receive the same message that the client node 1 just broadcasted. So we can assume that if the client 2 has been detected that the positive of COVID-19 and upload the CBF to the backend server, then if the client 1 send the request command to the backend server, the backend server will check if they share the same ENC IDs. On that circumstances, the client 1 will receive the result that he is the potential contactors. So, which means that if in the reality, the client 1 and client 2 are very far distance. Between the client 1 and client C, they never met each other. But the attackers use the relay attack. They will mislead the backend server to send the mistake response to client 1. Okay, for the next way, the attackers may use to attack our system. We can see that is a DOC attack. The reason is not the reason. If the attacker just used this way to attack our system, of course we can see that it can keep sending a lot of request message to send a lot of requests to the backend server. And during Wait a minute. Let me see how to see it. Okay. We can see that the attacker will perform a DOS attack by sending a very large amount of the QBF to the backend. During that circumstances, the backend cannot, the backend's network capacity has been fully congested by the attackers. So the backend cannot have any resources to respond to the normal client node. So through this method, the attacker will just uh, to broke the system's function that the generally normal, I mean the normal client will not receive any response from the backend server. Okay, let's see the stage 11C. On that stage, that we also gave some suggestions that we can prevent the relay attack and the DOS attack. For the first attack, that there is one way to avoid this by recording the IP address for each client node. I mean, it means that if we identify that too many shared key are sent in a short time by the same IP address, then any message from this IP address should be ignored from a while. Let's see we can see it from the terminal that okay, let's see from the terminal. We can see that the terminal will give us alert that a potential attack has been detected. Wait a minute, let me find this. Okay, I found this. Like this, the potential we can see. Wait a minute, we can see the segment 11A that the potential attack in the middle of the screen. We can see there are okay, in the last line of the of this one, yeah, we can see that the potential attack has been alerted. Reconstruct the share case failed with this one, like this. Okay, let's back to the description. That if we identify that the too many shares are sent in a short time by the same IP address, then any message from this address should be ignored for a while. And if the client report this event to the server, and the server received some numbers of this event, it means that the server can detect the potential attacker, because that's not the normal way that that's not the normal UDP broadcast that should be happen in the normal daily life of this system. Okay, for the if the server detected several reports regarding one same IP address, then this address should be blocked. Okay, let's move to the second attack. That we can set blocking mechanisms for a same client node, which means that for each client node, we can limit this ability to send the request to send the QBF request to the backend server. Which, for example, that we can limit each client that only can send queries per 60 minutes, per 60 seconds, or 3 minutes. By doing so, we can upload. We can just to reduce the risk that the attackers use those attack to our systems. Or there is an emergency ways that we can expand the server bandwidth as an emergency countermeasure to make sure the systems can be run normally to increase the robustness of our system. Okay, I need to mention that we have to do some trade-offs. For example, in order to make it easier for us to record this video, the sole reuse port we can Okay, my network's issue. Wait a minute, let's see the code. Okay. Broadcasting, UDP broadcasting, yes. Okay, we can use by use this we can to reuse the same UDP port, which allow us to test several clients in one laptop at the same time. Okay, and we can see that in the future, we can make some potential improvement because as we showed in this demo video, the UI is not very user friendly. In the future, we may can design a user friendly UI to make the systems easier to use. Okay, I think that's all part of our demo video. Thanks for watching. This video is from group 20. The group number is Yixi, Chen, and Shuo. Thank you.